This is the solution to the recoil problem. With these problems, it is really important to have a good picture. There's going to be a lot of data, so without a picture, you're not going to know what happens right before to right after, and you're not going to remember which are object 1 and object 2 and where velocities and masses go. So before we start, we always have to think about, when we're dealing with momentum problems, that momentum is only good as an approach to analyze right before to right after a collision, or in this case, right before to right after forces are exerted. So we can't look at distances, we can't look at anything like that. We look at masses and velocities immediately before forces were exerted and immediately after. So let's look at our picture. So what we have right before forces are exerted is a raft and a buoy. And we'll put in some data soon. And then what happens? Right after, we have a buoy. We don't have to draw pictures like that, and a raft. Now, why did I draw it like this? Because I read the problem to make sure I know what directions to look at. So I'm going to call it, when we start drawing things in, we'll be able to throw some axes. So I'm going to call the buoy M1. So look at how I'm setting these up. M1, 55 kilograms. I'm putting it kind of right below the buoy. Let me go right over it again. Let's call M2 the raft, which is 175 kilograms. So that's after the buoy jumps. Before the buoy jumps, we have one giant object. M1 plus M2 is the mass, which is 230 kilograms. So now look, we are saying before the jump, eastward at 1.45. So we only have one object, so we have this way, v initial 1.45 meters per second. By doing that, that means I have now defined x, I'll call that eastward. So now what? The buoy jumps off the raft westward. So this is V1 final with the arrow pointing to the left, 4.97 meters per second. And V2 final is what we're looking for. I'm not assuming any directions. You just draw a question mark. A good picture has everything you need. So now we have to set up the momentum equation. Pi equals Pf. So remember, it's masses and velocities. So here's how recoil works. We always write in a general equation without numbers first. So mass times velocity before. That would be m1 plus m2 times the velocity v0. The momentum after, m1 v1 final plus m2 v2 final. There's the general momentum equation. Now we can put numbers in. I mean, you could solve for v2 final or just put numbers in. 230 kilograms, m1 plus m2, 1.45 meters per second, equals M1, 55 kilograms. Highly important here. Look at the arrow. The arrow determines positive and negative. These are the things that we will look for when we want to make sure we don't make any mistakes. Negative 4.97 meters per second. I'm going to be looking for that when I grade your stuff, so be careful. Plus 175 kilograms, V2 final. Well, we can solve this for V2 final. And when we do, we end up with 3.47 meters per second. So what this tells me, because I got positive, that the raft is moving eastward. This is what it tells me at 3.47 meters per second. That's the direction of the raft. So, what do we know about recoil? In recoil problems, the way to think about it, one becomes many. One object to start becomes many at the end.